So when graphing quadratic functions in vertex form, it's very similar to just the transformations that were in the transformation video. But your vertex form would be y equals a parentheses x minus h to the second power plus k. In a quadratic function, if you have a 2 as the highest exponent, you know that it's going to graph as a U-shaped graph, which is called a parabola. If a is positive, so the number outside the parentheses is negative, if a is negative, your parabola is going to open down, and if it's a positive, it's going to open up. The vertex is found by doing the opposite of this number and then that number. So whatever that is, you take the opposite of what's sitting here, and then you keep this one. As far as the width compared to the parent, if it's less than 1 or bigger than 1, it's more narrow than the parent. If it's between 1 or -1, it's wider. And remember, in this case, a cannot be 0 because that would knock out the squared term. If it was 0 times this, all this would go away, and you would just have y equals a number, which would not be a quadratic. So let's sketch a few of these. So if I ask you to sketch this, you would find the vertex first. Vertex is going to be the opposite of that, so you would have -1, comma, and then there's nothing out here, so that's a 0. So that's your vertex. What else do you know? Well, your A is positive, so it opens up. And we can't graph this, but because it's 4, you know that it's more narrow because A is bigger than 1. Okay. All right. So that is how you do that one. So if I start another one, let's go ahead and sketch this one. So this quadratic would be graphed as -1, 0. So -1, 0 would be your vertex. It opens up. So there's your parabola sketched. Obviously, I can't show you that it's more narrow. I just know that it's opened up. And in my mind, I know it's more narrow, but I'm not showing that on the graph. All right, so what about this next one? The vertex. Again, in vertex form, it's easy to find the vertex. You do the opposite of this, which would be 3. You keep that one, which would be 4. You look at this number. If it's negative, it's open down. And because 1/3 is between -1 and 1, that means it's wider than the parent graph. Again, this is hard to show on the graph, but I'm just doing a sketch. So 3, 4 would be your vertex. I know that it's open down, and again, in my mind, I know that it's wider. Just to get a visual of that, it's wider than the parent. All right, the next one, you do the opposite of the parentheses. You keep what's outside. So -8, -3 is your vertex. This number is negative, so it opens down. And 4/7 is in between -1 and 1. So that means that it's wider. I'm not going to show that on the graph. But your vertex is -8, -3, which will be down here, and it opens down. Right, now this one is a little bit different. I wrote it differently to show you what I meant by it. This is probably something you would not see. This is how you would see it written. So here in the parentheses, there's no transformation. There's no left or right on this one. So if it doesn't have it, that vertex would be 0. And then this +1 would be your K, because that is in vertex form. So 0, 1 is your vertex. Your 5 is positive, so it opens up. And the 5 makes it more narrow. So if I sketch that 0, 1 is here, and it opens up, and it's more narrow. All right, and the last one I'm going to do, the vertex is -2, -3. This number is positive, so it opens up. 7/4 is bigger than 1 because 7/4 is 1 3/4. So that means that it's more narrow than the parent. Just because it's a fraction doesn't mean that it's wider. It has to be between -1 and 1 if it's wider. That number is above 1. So -2, -3 would be the vertex. It opens up, and there's your sketch. And that's how you graph quadratic functions in vertex form.